Uh, Welcome to video 2A. You're going to be doing parallel lines and transversals. Before we get to that, we're going to cover some basic things about lines, in particular slopes and what makes lines parallel in the first place. So you need to remember from Algebra 1 how to get the slope of a line. And if it's off of a graph, remember you just do rise or fall if it's negative, so keep that in mind. If the line is going up, you'll use a positive because it'll be rising. If it's going down, we'll have a negative on the top. So sometimes it's helpful to write rise or fall on the top. And then on the bottom is your run to the right, technically. So the formula for it that you learn in Algebra 1 is to subtract the y's, and that does tell you the change along the vertical, which would give you how much it's rising or falling. And on the bottom, it'll say subtract the x's, which does give you the change along the horizontal or how far you're running. So keep in mind that your answers for slope should be positive anytime your line is rising, or when you're walking on it, you're going uphill. Likewise, anytime you're going downhill, you better get a slope that's negative. You'll have a slope that's 0 along a horizontal line. So this would be, and let's put our variable for slope on there as well. Some people wonder why they call it m, and I guess the answer is why not. You don't want to use s because it looks like a 5, l looks like a 1, this looks like a 0, p is used for probability, and e is a number. So you're kind of out of choices, so we go to m. So your m on this one, or your slope, would be considered 0. M on any of these will be considered some negative number, and the steeper it is, the larger the negative number is, if that makes sense. Over here, your slope is positive. An undefined slope, and this is kind of like you're walking from to the right, and you're walking uphill, so positive, you're driving downhill, so negative, you're driving on a flat road, so the slope is 0. You can't drive on this, you're going to fall off of it. So sometimes that's a helpful way to decipher between this case right here when the slope is 0 and this case over here when we're saying it's undefined. If you can drive on it, it has a slope. If you're going to fall off it, we say it's undefined. Or sometimes you'll see it'll say it doesn't exist in higher levels of math. So that's just some algebra behind the slopes, and we're going to be working with parallel lines in particular, maybe delve into a little bit with perpendicular. But lines are parallel. Let's go put a pair on here. You can't run parallel unless your slopes are identical, because eventually, if they're not, you are going to cross. It might take a while, but if I have a line going like this and I have one just a little bit off, eventually, as I continue to head on out, they're going to cross. So we say lines are parallel, and I've got a typo here, if they have and I'll write a little slower, same or equal, they have the same slopes. So regardless of whether you're working with them algebraically or graphically or just given points on the line, once you find the slopes, if they're identical, you'll conclude that the lines are running parallel. So first of all, graphical interpretation. If I were to find the slope of this line, I'm just going to walk, and again, we always walk to the right, it makes it easier. So I'm going to walk to the right, and I'm going to think, well, how do I get from this point to this point? I'm going to have to fall 4 and run to the right 4. So you would say your slope takes you down 4 over 4. Or if you didn't want to go that far, you could say it goes down 1 over 1, which is what this reduces to. So we've got a slope of -1. Notice it's going downhill, so that's confirmed that I should have a negative. Any line parallel to this will also have a slope of -1. So go ahead on here and throw another point over here in quadrant number 3 and slope it out. So go down 1 and go to the right one, put another dot, and connect them. And you will invariably have two parallel lines. So for graph, lines are parallel if their rise and runs give you the exact same slope value. So next up, even though there's not a whole lot about perpendicular on your next worksheet, I'm going to bring it up because it's just as important as parallel. We spend a lot of time in geometry talking about the parallel lines, but perpendicular is just as valid. So let's go up to this original one. up here. I'm going to take all the stuff off, and I'm going to try to draw a line perpendicular to this one. So let's go right here, and let's see if we can draw one perpendicular. And remember, that means it has to hit at a right angle, or it has to hit like this. So let's try to create that in here. I'll make a little T here and head this way and head that way. You'll notice that to make them go perpendicular, if one had a slope that was negative, the other one has to have a slope that's positive. So their signs are opposites. So part of the perpendicular, let's write this down, lines are perpendicular. I'm just going to use the symbol if their, whoopsie, slopes are, first of all, I just figured out that they have to be opposite. In order to cross like that, if one's going up, the other one's got to go down. So if their slopes are opposite, I should write that in another color, but let's underline it. So first of all, they have to be opposites. And you'll notice that this line up here had a slope of -1, and my new one has a slope that's perpendicular of +1. So it's a little hard to see what the relationship is when I'm working with ones, but I know for sure they have to be opposite. What I'm going to do is throw a different line up here so you can see really what's got to happen with the perpendicular one. I'm going to make a line that goes up 3 and over 1, and draw it as best I can. I missed it a little bit. And then I'm going to try to draw one perpendicular to it. I know it's going to have to go downhill, but watch me go, instead of up 1, 2, 3 over 1, I'm going to go down 1 and back 3. And when I flip it and reverse that, you'll notice I get that nice perpendicular relationship. So if one of them is going up really steeply, the perpendicular one has to go down very gradually. So there's also a reciprocal effect here. If this is going up 5 over 1, this is going to have to reverse that so that they meet nicely. Anyway, opposite, and our word for flipping things is called a reciprocal. Another way to say it is that their products have to be -1, but most people don't like to do that. So we're just going to leave it at opposite reciprocals. But back to parallel lines, and I think did I have anything more at the bottom of that page? I feel like I'm leaving something out. Nope. All right, so I'm good to move on. On the next one, we're going to work a little bit with slope-intercept form of a line before we get to more on parallel and perpendicular. So again, a flashback to Algebra 1. Slope M, intercept B. Why B? I don't know. Why not is the answer to that. Y equals mx plus b is what we call slope. So let's point at that. And I'm sure you remember some of this from Algebra 1. And the b is the y-intercept. So it's where we hit the y-axis. So I'm going to have you take a second. We're going to go back. It says for the line above. I don't have one above. I think I want you to go back over here and look at this line. I'm going to erase all the extras off of it. So in order for you to write the equation for this line in slope-intercept form, you need its slope. We already found that. It's -1. So I'm going to write that over here. We'll come back to it in a minute. I also need its y-intercept. Well, here's the y-axis. I need to know where my line intercepts the y-axis, and that's up at 3. So we would say b is equal to 3. So you pluck both of those off your graph, and then you put them in this model. It'd be y is equal to -1, x plus 3. And normally you wouldn't see that there. It would just be y equals -x plus 3. And to repeat, that's how you write your answers whenever it says in slope-intercept form. So again, we said that lines are parallel. Go ahead and block that and go point if they have the same or equal slopes. So if I'm given this line, which is in slope-intercept form, a line parallel to it will have the same slope. And the same slope, the slope is indicated by what's in front of the variable x. So any line with a slope of 1/2 will run parallel to this line. So it says write equations for 3 lines that would be parallel to that one. Well, they all have to be 1/2 x. So let's go like that. Here's the start of 3 lines running parallel. They're all going to go down 1 over 2, so they're going to be a little bit gradual. All I need to do to make 3 different lines is shake up the y-intercept. I just can't use -5. So you can pick any number. You have an infinite amount of correct answers to this, but let's just go like that. How about put one way up there? That's a 999. Go graph that one now and show every tick mark. Just kidding. All right. And then let's make one go down below. So what I'm doing with this is I'm keeping the slope locked in. It'll keep it running parallel to this one that was given up here. But by shaking up the y-intercept, what I do is I move the line down or up, depending on what I put on that. So to repeat, lines are parallel if they have the same slopes. Off of a graph, you get the slope by rising or falling and running. Off of an equation, you get the slope by what's in front of the variable x, as long as it's in the form y equals, let's put this in a box, it's box worthy, y equals mx plus b. So have a good one. After this video, you should work on worksheets 2.1 and 2.2 and get my signature when you're done, and then move on. Ciao for now.